Howdy folks, in today's video, or this video, we're going to look at the TopDiag Smart Hook. Not the catchiest name in the world, to be fair. What this is basically like a cheaper version of a power probe. It's got quite a lot of stuff packed into it. So in your DIY automotive mechanic arsenal, you're probably going to have things like a multimeter, which I would definitely recommend, and probably an OBDII tester to be able to have a look at the ECU and see what codes the ECU is putting out, that kind of thing. This is a little bit different. This will test circuits and various bits and pieces. It will do the multimeter functions, but it does a lot more besides, and I'll go into all of those for you very shortly. Straight off, this is the first time I've actually looked at this. I've not even taken it out of the box. Just a couple of things. Chinese manufacturers, I don't know why you use these colours. They don't promote a quality item, in my opinion. I don't know, people, put your... What do you think about that in the comments? Do you look at a box sort of designed like that with these kind of weird colours and go, dodgy, not sure. Okay, anyway. So, first thing is, I'm not overly struck with the case. It's kind of a hard case, you know, it's solid, it's not like a soft bag, but it's like a cloth finish. Now really what we want is a plastic hard case. One, so it'll take a bit of punishment, but also we want to be able to wipe it clean when we get grease and things all over it. A cloth surface on a tool for a car or a truck or whatever, it's just not going to, you know, it's just going to get very grubby very quickly. So, in any case, so let's see what we've got. So we have the main cable and the tool itself, the connecting leads to the car battery, because this doesn't have its own power supply. It doesn't have batteries, it doesn't plug into the mains, it plugs in or onto your car or truck battery. It operates between 9 volts and 30 volts, so it will do 12 volt, which is most automotive like motorcycle and car systems, and it will do 24 volt as well, which is a lot of trucks and lorries and stuff like that. But it hooks up to the battery of the vehicle itself. It doesn't have anything else. So all kinds of probes and connectors. There's a USB cable there, to go into that in a second. You've got a user manual, and there's a user manual on here. There's also software, and there's also some videos on there of how to use various things. They don't go into a lot of depth of the detail. So let's get rid of that case. So manual, first thing we like to have a look at perhaps is the manual, and by look at the manual I mean have a quick flick through and discard it, because as I say, it is only the manufacturer's interpretation of how to use a product. How to do each test, so that's quite good. Not a bad manual, got to say, and you know, it can live in the case, so that's good. So let's unpack this. Okay, so okay, perhaps I won't tear that down then, perhaps I'll just tear that off and then peel the, well, I'll leave that, there's a protective cover on there, I might as well leave that on. So my first impression is that if it is solid, it's a solid unit. That'll take a bit of punishment, I reckon. The buttons on it are rubberized. I don't know if you can hear that. They've got a positive click on each thing, each operation. The cable itself, chunky old cable. You got a connector end, and that's the main end to hook onto the alligator clips for the battery. I'm not overly struck with this plastic. I mean, it's tough, don't get me wrong, it is solid. It just doesn't look very great. It could look a bit better. But what I don't like, I would much prefer this to, you know, you get that stuff that's like, it feels soft, it's coated in that like soft feel. It's almost like a rubber type feel, but it's not. And what happens is over a period of time it tends to go tacky and horrible. I wish You know, I'm glad it's not covered in that to try and make it feel more expensive. I mean, I'm never happy really, am I? I don't want it coated in that, but I'm not happy with the plastic. I mean, it's tough enough, and that's all you need. So there's a USB cable here, and that is for updating. So lead wise, you've got probe, thinner type probe, which is useful actually trying to get into all those tight spots and on the end of terminals or in connectors for things like ECUs or ABS sensors, that kind of thing. You've got a set of activation leads here, and this is what plugs into this top port here. That folds out the way at the top there, and that plugs in there, thus so. These here, press on the end, and that is in there snug. That is not coming out until I remove that. That's not coming out, so they're in there good and tight. Yeah, on the back here is a Velcro strap to keep the cable nice and tidy. On the back here, right, so what we got here, as I say, there's the connector for the crocodile clips, you know, these bad boys to go into the battery. You've got a negative probe for doing you know, full circuit testing, and this is the fused end as well, so it's very easy to change the fuse there. It's a 25 amp fuse. The thing is fused, and it does have circuit protection as well, which is a bonus. And then this here is your USB socket for updating it. So you've got the probes, there's a alligator clip to go on the end there for putting your own leads and stuff on. And then we've got an extension lead for the probe end as well. So when connecting the crocodile clips to the actual device, what you're not going to do is plug it in the wrong way in error, because both sides are handed, if you like. They can only go in one way. And there's a slight ridge there, so they're not going to come apart too easily. So they're not going to, like, you're not going to pull on the lead and accidentally unplug it, as it were, because they clip together quite nicely. So let's get this thing hooked up. There's a handy light on the end there. Okay, so let's do some basic function sort of tests to show you the sort of thing that it does. So to make this a bit easier, I've attached the extension cord for the positive probe, and we've got the negative lead here, and that's got the crocodile clip. I'm going to take that off for the first test, because I'm going to test a drill battery, and that's where this other little probe will come in quite handy. So the first one we've got is smart, so I'm going to select smart. So remember that this is the battery that the probe is connected to, that it's taking power off. Our readings come from this screen here. So we've got sort of standard 18 volt drill battery there. So let's just take a reading off of this, and I think it's pretty well charged. It's automatically detected that we're checking DC volts. We can see that in the red symbol at the bottom there, and it's reading 18.5 volts. Now let's get something to see if it will check resistance. Okay, so just off camera I've got a power regulator, 12 volt power regulator. So let's just cut it across two terminals. Now what it should do, it should show us ohms, because we're measuring resistance. So let's see how we get on. There we go, and it's gone to ohms for resistance. And that's 220, 221 ohms. The smart function is quite useful if you're just wanting to check easy things like voltage or resistance, that sort of thing. So we'll come out of that screen. Let's move into multimeter. So this will give you more options. So let's just go back to the battery again, and you'll be checking this for car applications, I understand, but it's raining outside. So okay, so once again we're on the battery, 18 volt. ohms. So let's go back to our power regulator. I can get the probe in there. There we go, 220 ohms as it read before. Diode test as well. And then ampage. And then the last one is frequency duty. So on the power regulator, it's given us a reading of about 5 to 5.6 of 50 Hertz. The specification for the part will tell you what parameters, you know, what readings these should be. So that's where that is going to be able to help you. Because if it's within the tolerances that the manufacturer states, so for example for the power regulator, if it's stated it should be a certain frequency and duty or that kind of thing, and it's outside of those, well then you know you've got a faulty part there. So let's just return out of that. Now the oscilloscope setting, I don't have anything, I don't think that I can take a reading of, and to be honest I'm not going to talk about this aspect of it too much because I haven't used this kind of thing. I haven't got anything to test it with in terms of providing a frequency, and I don't understand it properly. So what I would suggest is perhaps have a look at some other videos to look into how you're going to use it if this is what you're specifically going to be buying this product for. So apologies for that. Same with relay. So as I've said before, I haven't got a relay available here to plug into, but if we did have, the manual tells you which of these terminals to connect the 3 leads up to. It will cycle the relay, it will activate the relay and be able to tell you whether the relay is good or it's not working correctly. So active is you activate components, so that could be a bulb, it could be a window motor, that kind of thing. So it's quite useful to be able to provide power to a part without it being plugged in, so then you can understand, okay, is the part faulty or is it the wiring or the power supply to the part that's the problem? So for example, we'll use a, let's just we'll change the probe back to a crocodile clip. Let's take a bulb for example. So I've got just like a standard, I think this might be an H1 fog light bulb, something like that. See, fog light's not working now. Invariably it's going to be the bulb because bulbs blow, but it gives you the option to test the components, and there's 3 options. You've got momentary, so that's you press the button for the power and the power comes on, you release the button and the power goes off. Latching, you press the button to put the power in, it stays on till you press it again and then it goes off. And then pulse is you press the button to turn it on and it turns the power on, off until you press the button again, then it turns off. Now the amp setting will be the amount of either the amount of amps that you're putting in, so you can adjust up and down on that basis for what amps. Now we're going to test a bulb, so I'll put 5 amps through the bulb, but let's just see what it does at 1 amp, because what that's quite low for this is a 55 watt bulb, so it's probably not going to draw enough current. So before we just zoom it out to show you what the different modes do, let's just see, it should tell me it's a bit unhappy about life. So positive. Okay, so the bulb's on and it's said, see that again? Current overload, please increase the current. So we're not sending enough current to the device to operate it. So I'm probably looking about 5 amp. Let's put 5 amps, I'm sure that'd be plenty. So momentary, we'll press it on and we can see the bulb. You see in the background the bulb's lit. So I'm going to zoom out and I'll show you the 3 different things. So there's our bulb. We're on momentary, so we're going to press. It will test the component. We know this bulb's good. It will light. I'll lift off. It will go out. So this is momentary. There we go. It's only on for the moment that you're pressing it on. Okay, so then latching. You press the button, it stays on. You press it again, it turns off. So that's good if you need both your hands to be doing things and testing. But remember that whilst that's on, it's live. And then pulse is it will be on, and I think it's 5 seconds. It's on for 5 seconds and off. So, and that'll keep cycling the current through the probe to your component until you press it again, and that'll stop it. And there we go. So that's how you'll use this to test components, and that is going to be very useful, and probably one of the primary reasons that I'm going to use this for. Because when things fail, testing the component when the only way you've got to test it is plug it into the wiring that is supplied to it through its own proprietary connector can be a pain if you don't know if it's the component. So it might be a motor, a bulb, or something like that, or the component is the component or the wiring itself. Is there a break in the wiring? Just a couple of things to talk about in the active, which is the component testing. Two things. First off, do not use that for testing delicate electronic components like ECUs and things like that. You will absolutely fry those things. Also things like airbag systems. I mean, personally I wouldn't be testing airbag systems. I've taken steering wheels and things off in my time, but that's once it's been disconnected and any residual charge is dissipated, things like that. And if the current flowing through the probe is more than the value that you set, so it's trying to draw more value than you've put it at, it will cut the power off to protect the circuit. So the next one is a 0 to 5 volt power supply. So this is useful for checking wiring to the ECU. You can use in tandem with these, as I said at the beginning of the video, one of your key tools in your arsenal, if you like, for diagnostics is going to be an OBDII reader. So you can use that to diagnose the result in the ECU, and then use this to set power supply voltage in half volt increments up to 5, maximum of 5. I don't know an awful lot about this aspect of it. ECU testing is not something I've ever done or I've had to do before. So again, I'll do it if you're looking for that. I'll do a little bit more research into that before you know this is going to suit your requirements. So we'll come out of that. Next one is injector testing. So there's 4 modes for the injector testing. Mode 1 will output 1 pulse, so 1 shot if you like, at 250 milliseconds, and then it steps down. So mode 2, it'll output 50 pulses at 7 milliseconds, and then mode 3 is 100 pulses at a width of 4 milliseconds. And then mode 4, it's continuous, so it's continually pulsing a rate of 50 pulses in 1450 milliseconds. And every one of those pulses is 7 milliseconds. So you would press to start and then press again. You press OK to start, sorry, and then you press OK to stop on each one of those. I don't have an injector to test, and yeah, I'm afraid I'm not going to be pulling down my car to get to the injector to pull one for testing. So lastly, we have positive, negative. What you would do with this is you would connect the negative cable, so the negative or ground cable to the vehicle ground, and then you'd use the probe tip to find the positive or negative wire. So attach this clip to an earth point on the chassis somewhere, and then you'd use the tip to find which was the positive or and it will tell you. So let's see if we can mock this up in some way. So let's go into that. So I've just used our bulb. It's a bit of a rudimentary way of doing it, but it's just the same thing because it's just using the circuit. So attach the bulb, and if I put it onto the negative terminal, which is the back terminal, then it tells us that that is the negative. It'll tell you it's one or the other. Now, I don't know about you, but most of the time I'm poring over wiring diagrams or asking questions in forums. Can you tell me out the 10 wires coming out of this block, which one is the ground or which one are positive feed, so I can jump a power line off it? So this is going to help you find that in seconds. And then obviously our setup screen. So what do I like about this thing? The lead length is awesome. The screen is easy to read. It comes with pretty much everything I think I would need to fulfill what I need to do with this product. There's lots of things that it does that I don't have anything to do to undertake those tests at the moment. I've got a multimeter that'll do basic tests. I've got OBDII readers, but things like the oscilloscopes side of things, duty cycles, being able to provide power to components to test them, that kind of thing. And it does have, you know, the multimeter side of things built into it as well. So if you don't have a multimeter, then this would undertake those functions. Now obviously it does have to be connected to the vehicle to draw power. Depends what you're going to use it for, but you could dispense with buying a multimeter if you wanted both. If you think, I need a multimeter and I need one of these things to be able to test certain functions, then this will undertake both of these. What don't I like about it? I don't like that case, that's horrible. If the manufacturers get to watch this, please change that case to a hard case. And in the hard case, please change it to a case that will allow you to pack it away in a tidy way. An empty box, you're just kind of just throwing the whole thing in there. It's just going to sort of rattle around all over the place, not do so well. It is fairly expensive, or you might look at it and think it's fairly expensive, and it's going up against things like Power Probe 4s or you know, whatever the current ones are. It's currently £127.20 in the UK. I'll put links if you want to be able to buy one to Amazon, which is where this came from, in the video description. As I say, it comes with 20-foot cable. That is really useful because you hook it up to the battery and you just wander around the whole vehicle, test, you know, front to back. You'll be able to test everything. You don't need to worry about not having enough cable to be able to do that. As I say, it works on 9-volt, 30-volt systems. It operates in temperatures of 0 to 60 degrees Celsius. So I sincerely hope I never have to use this in 60 degree Celsius heat. I think that'd be the least of my troubles, that my car's not working. If you're in a significantly cold climate though, sub-zero temperatures, you might find you struggle with this, so that's something to think about. But then a lot of electronics are like that. They don't like the cold very much. As I say, it does have short circuit protection, so it will prevent you as best it can from you killing it. And it does have a replaceable 25 amp fuse.